Alright, in this sample problem on slide 89 of our chapter 11 PowerPoint, we're going to be working a problem utilizing Dalton's law of partial pressures, which basically states that the total pressure of a gas mixture is equal to sum of the partial pressures of all the gases in the mixture. So in our problem, we are dealing with a heliox breathing mixture of oxygen and helium, which is typically prepared for a patient with chronic obstructive pulmonary disease, sometimes called COPD. So in our problem, the gas mixture has a total pressure of 7 atmospheres. And if the partial pressure of the oxygen in the tank is 1,140 millimeters of mercury, what is the partial pressure in atmospheres of the helium in the breathing mixture? So first thing I'm going to do is write my equation for the total pressure in this gas mixture. So depending on what your mixture contains, your equation is going to be slightly different, but they're all going to start with pressure, total pressure, equal to the partial pressures of the mixture. So in this mixture, tells us we're breathing heliox, which is a mixture of oxygen and helium. So the total pressure in my Dalton's law equation is going to be equal to the partial pressure of oxygen added together with the partial pressure of helium. And in our problem, it states that our total pressure is equal to 7 atmospheres, and that the partial pressure of oxygen is equal to 1,140 millimeters of mercury. Now, hopefully you've seen that we might run into a little bit of problem here if we're trying to figure out what my pressure of helium is in my mixture. I'm currently in 2 different units of pressure, my pressure total being in atmospheres and my partial pressure of oxygen being in millimeters of mercury. So we're going to have to convert one of these to a different unit of pressure. Now, if you have been following along reading the PowerPoints, if you go back and consult slide 24, let's see if I can find it on here. 1 atmosphere is defined as being exactly 760 millimeters of mercury. 1 ATM equals 760 millimeters mercury. So this is just like an equivalency that we've talked about in any other chapter. I could state that there's 1 atmosphere per 760 millimeters of mercury, or I can say that there are 760 millimeters of mercury in 1 atmosphere. So if we go back to our problem on slide 89, the answer is asking us to solve in atmospheres. So I'm going to leave my total pressure alone because it's already in atmospheres, and I'm going to determine what atmospheres my partial pressure of oxygen is. So we're going to take that 1,140 millimeters of mercury, and we're going to basically divide by 760 millimeters of mercury and multiply by 1 atmosphere. We're going to use the equivalency that we just wrote down. So if I divide 1,140 by 760, I get that the partial pressure of oxygen is 1.5 atmospheres. So now I'm in the same pressure unit, and I can use my Dalton's law that I've set up at the top to solve for the partial pressure of helium. So we're going to come down here, plug into this equation my total pressure, 7 atmospheres, and that's equal to partial pressure of oxygen, which is 1.5 atmospheres, plus the partial pressure of my helium, which is what we're trying to determine. So then it's just a simple algebra problem when we subtract 1.5 atm from both sides, and we get that the partial pressure of helium is equal to 5.50 atmospheres. And that's the answer to our problem.